Welcome to Modular March. I'm Andy, this is Robbie, and we are The Rollup.
Modular March is an educational experience about all things modular. Enjoy.
Welcome back to Modular March. I'm happy to be speaking today with Tarun from Gauntlet. Tarun, welcome. Would love to just give a quick, brief introduction about yourself, and then we'll dive right into some of your thoughts with regards to value accrual and the modular stack.
Hey, thanks for having me. I'm Tarun, founder of Gauntlet, and we do sort of risk modeling, risk management throughout DeFi and kind of the L2 ecosystem. And we, have been spending a lot of time thinking through both value accrual as well as risk properties within everything from restaking to data availability. I've also written a lot of sort of academic papers on things kind of related to this. So that's sort of the TLDR.
Yeah, I mean, I noticed when I asked kind of what you'd be interested in, it was value accrual in the modular stack. And I think there's like various theses going, being passed around right now. So maybe we try to set a foundation for kind of what your general perception is or kind of overview for how value will accrue in the stack.
Yeah. So, I mean, I think, if we look at computing in general, there's kind of been this historical divide, almost like two very separate camps that are it sort of reflects the current sort of modular versus monolithic kind of dichotomy, which is, do I optimize for really low latency but not high bandwidth, or do I optimize for really high bandwidth but things are asynchronous, like they're not happening at the same time? I can't give you any guarantees about how time passes between the two objects. I can only tell you some relative properties of them. And I think, historically, if we look at the internet, the earliest parts of the internet and the earliest parts of compute and where it intersected with finance were really focused on this kind of low latency stuff, right? Everything was really about like, how do I make these financial systems very efficient? How do I, by reducing latency, I can make price discovery more efficient, etc. And there's a sense in which the modular thesis for normal computing kind of only became interesting once we had applications that were kind of not working as well as they should, right? Like when we had sort of the Twitter fail whale and like Facebook was going down all the time in like 2000 to 2010. And so there's kind of this interesting thing where like in the 90s, a lot of the investment, a lot of the interest was in the kind of low latency, single gigantic machine type of thing. And then it kind of eventually moved to this more distributed thing. Now, of course, there's still tons of places where the lowest latency performance things are really important. So lots of places in trading. So like when I worked in algorithmic trading, like that's a place where you care so much more about latency than bandwidth. But on the other hand, for something like a Facebook, a Google, OpenAI, you care a lot more about bandwidth because you just need to have enough throughput to handle a really high variety of different demand sources, right? Like the person who's going into ChatGPT, getting help with Copilot for coding is very different than the person who's going to ChatGPT to be like, write my emails. And training these models for those different use cases is a very sort of heterogeneous workload. So why did I kind of give this sort of long backstory? There's sort of the sense in which the highest value in these kind of modular asynchronous systems is derived when you have very heterogeneous workflows, like workflows with different demand characteristics. Like, some types of things are like very regular transactions, but maybe small value or small quantities. Some types of things are, there's basically no activity, but then a ton of spike in activity and then no activity again. That's like an NFT auction. Whereas the first thing is more like a DeFi protocol, and being able to handle these like heterogeneous demands safely and efficiently oftentimes works better in the modular world versus something that's homogeneous demand. Like there's a particular application that specific application you're trying to tailor, low latency and performance for. And so I think the modular stack within crypto still hasn't figured out if we're being completely honest, a value accrual story, because there's no applications that have these kind of heterogeneous demand behaviors like, Facebook does or Instagram does, right? Or like, where like, if I think about Instagram, right? Like if I imagine I could make a map of all the different Instagram accounts, and I could just show you like a heat map of like, and imagine there's somehow locality sensitive. So like people who are connected or clustered nearby, just like a 2D map. And imagine I could give you sort of like a heat map of, hey, which accounts are having a lot of activity, which ones are having low activity. You'll see that like the demand distribution changes throughout the day, the kind of like which types of accounts are posting and generating a lot of load on the network at Facebook will depend on the day, depend on events, right? Like right around the election, you'll see the whole map red. But maybe on maybe like right after New Year's Eve, you actually see this huge demand depression because like people were posting a lot right before, and then it and this is what I mean by these kind of like heterogeneous demand distributions. Now, crypto apps right now are just very primitive because there are a lot of like finance and trading apps or NFTs or very minimal games. And because of that, we haven't had any apps that really have benefited intrinsically from the fact that you could have heterogeneous demand distribution. So I think one really important thing to people building applications in the modular stack is to figure out if your application has this kind of property where sometimes you just have very different usage of the system and you want to outsource different components of the high usage and low usage times to different modules effectively, right? That's when you get the best benefit. And I think application developers, web developers who want to think about when it's optimal and when value accrual occurs, it's in that part of the world. And the reason for that is when you have these heterogeneous demand distributions, you can specialize components to handle different types of workloads, different types of compute loads, different types of transaction loads. And when you have a large amount of usage, that you kind of get this like economy of scale from that. And I just think we're just in this nascent stage where like there hasn't been like the Uniswap moment for modular stuff where like it's an application that takes advantage of this ability to specialize. And I think that's the thing that we're all on the looking out for. So sorry if that was like a bit of a rant, but
yeah. And I was on with Brendan Farmer at Polygon, and we kind of were talking about this thesis earlier about how what's going to kind of happen is a lot of these stacks are almost like commoditized, very down to low fees, not very focused on rent extraction and things. And kind of what's going to happen is there's going to be a big hit that is built on these stacks, which is like, oh, the reason why this hit is possible, this game, this application is possible, is because of the stack which it's built on. And that's kind of like this Uniswap moment of adoption there. And so I think that these stacks may not, have individual value creation. Like it might be hard to tell which one, like DA or execution, et cetera, will be, the most profitable per se. But I think the applications which are built upon the stacks kind of speak volumes for the stack itself.
Yeah, I mean, I think there's just kind of this thing where you really need to understand what types of applications need specialization. And I think right now we are still in this part of the market where people are trying to take things that have worked in crypto and say, hey, look, if you did it in the modular world, it's better. But that's not always true, right? Like things that rely on liquidity really rely on, the liquidity kind of being aggregated. And obviously one of the kind of costs you pay for asynchronous communication is aggregation is more expensive than it is in the monolithic world. And so I think there's sort of this question of like, how do we get developers to start thinking about applications that take advantage of these things rather than like strictly trying to port existing applications that exist. And I think that's where I think things like gaming and like native on-chain gaming are like more close to taking advantage of the modular stack than DeFi, for instance.
And what specific parts of on-chain gaming or other applications do you think are like more expressive, which are better suited for the modular stack?
Well, I think the way to think about if you've ever written a game in like Unity or Unreal, is like the structure in which you write your code, the way it gets executed is already inherently modular. So I have maybe say and this is a very simplified version of what a game engine does, but I think this gives you an idea of why specialization helps. So, I may have a set of modules for defining characters. So that's like defining characters I can move, the set of actions they can take, the set of states they can take, what sort of features they have. Like maybe they have a health feature, maybe they have a hat feature, maybe they have an wear glasses feature. Then I have states that are like, what is the landscape? What items are allowed on the landscape? What objects are allowed on the landscape? Then we have sort of this notion of what actions can those two things do to interact? And you could think of those as two separate modules. In fact, oftentimes when you're playing a game, they'll be running on separate threads or separate cores of like the characters are like assigned to this one queue. So there's like one processor that's dealing with the characters moving in the game, and that needs to have high responsiveness. But then there's one queue that's dealing with like the landscape, and maybe that doesn't have to change as much, or it outsources to the graphics processor. And that very simple dynamic is something where separating the components and having them run separately and independently is more efficient than having them run as one full object. Because if you had to run them as one full object, maybe there's a ton of character updates, and then all of a sudden a landscape background update. But the background might take 100 times as long as the character. So now the characters can't update their states. Like the user is just like hitting like move. And instead it's like waiting for the like sun to turn into a moon. And I'm making up some kind of like example like that. And so I think games inherently are built this way because they already kind of have these components, and taking advantage of those components in sort of different modules is a very natural thing to do. The question is, within the crypto stack, there need to be some like economic interactions between them. So what are the economic interactions between the character chain and the landscape chain? And that's the stuff that people have to figure out, right? Like what the value has to come from, like people want to pay to make their character change the landscape more or something, and I think those are the types of mechanics that a lot of people working on on-chain games, are playing with, right? Like everything from Dark Forest onwards has sort of, and a lot of the autonomous world stuff has plays with this idea that like these modules, unlike a normal game, now it costs something to transfer between them. And I think that's where we'll see a lot of things that are, probably better for the modular architecture than say DeFi. Like I think there will be stuff in DeFi, but it will look very different than what we see now.
Got it. Yeah, it's a good example because it's something that I think is understandable for a lot of folk, and generally breaking down these kind of individual components. So I think like the key thing that we're getting to here is the value accrual will come from people and developers and builders thinking about what innovative concepts can be built only using these kind of specialized solutions, and then kind of how to kind of put them and go to market with them. Whereas now, right, we're still almost in this nascent stage. And I'm curious if you can draw any parallels to the current state of kind of modularity to any early emergence of tech, crypto or non-crypto, that you've kind of seen. I know that we kind of touched on the Instagram and the AI stuff, and I think there's probably some parallels there as well.
Well, I think the modular stack is like equivalent of like moving from like on-prem servers to the cloud, right? Because like once I'm willing to outsource different components and not have to own the entire hardware stack, then it makes sense to separate the components that I'm like, I want to outsource versus the stuff I want to do locally. And inherently, like the entire data center industry and the entire cloud industry was built around separating these components, outsourcing some pieces of them, and providing APIs so they could interact with each other. And I think, you know, the culmination of that was sort of this sort of microservice boom of the 2010s. But I think like people have a more negative view on what microservices are now. But arguably, a lot of the modular stack looks kind of like microservices. I think the difference is that in crypto, you somehow need to have a way of there being real financial interactions between these components, and like such that, you know, maybe it's like, hey, by, you know, splitting my computation in two, doing them in two different places, and having different fee structures for the two things, I actually make it cheaper for the end user, right? Because like at the end of the day, it's not that the cloud is more efficient than on-prem, right? I can just buy a much better server than the one I'm using Amazon. They're also virtualizing, so there's some overhead for the virtualization, all of that type of stuff. But it's that I can do it for way cheaper and on demand. And I think like those are the value props you need to get out of these systems for them to have a huge amount of usage, versus kind of the monolithic stuff where it's like all we care about is performance, which to be honest, right, there are a lot of applications where that matters, right? So I think like they both kind of are the yin and yang of this kind of world.
That points to a thesis that Andy and I think share, which is that the value accrual ends up at the user. And because it is more on demand and it's more convenient and it's more affordable for the end user to access this like cloud compute version of blockchain in the modular stack, now they're able to benefit through cheaper costs. And that's ultimately where value accrues, because essentially all these pieces of infrastructure are commoditized, fees are driven down through competition, and then the end user is offered the services at the best price because of the specialization at each part of the stack.
Yeah.
Is that a...
Yeah. I do think the value accrual story is probably to the end user, right? Like if we ignore token prices, you know, the value accrual of Celestia for AVO users who trade on AVO's rollup, it's not like AVO or Celestia is getting that much value out of the migration. In fact, it's the AVO users who are getting the highest utility increase from like their costs going down, right? And so I kind of think modularity looks like the cloud in that way, and that it's more about the costs going down and also the cold start problem going down. What do I mean by cold start problem? If I think about, you know, companies prior to having to get cloud servers, and I have a huge upfront fixed cost of building my own data center, and then I have a huge upfront variable cost of maintaining the data center. So, you know, I have to do a lot of calculations to amortize that cost to make it cheap. Versus in the case of the cloud, I can aggregate many people's calculations and amortize that across the hardware spend I made. I think modular applications inherently need to have the same kind of amortization type of property for it to work. And I think that's why you're likely going to see much more of the utility driven to the user and not to the networks. Like I think like for a long time, their tokens are basically going to compensate as a subsidy for the fact that like the networks are not going to generate much in fees until they've aggregated so much demand that it's possible, right? Like a cloud provider probably, you know, in a lot of cloud economics, and I think this is why we have ended up with this kind of oligopoly of cloud providers. There used to be a lot of small bespoke cloud providers, and they've kind of died. Is that a lot of cloud providers lose money on a lot of API calls. There's some API calls that they make a ton of money on, but there's a lot that actually cost them money, but they have to service them to retain the user. And so it becomes this question of like, how long can you subsidize that type of behavior? And I think the tokens in these networks are effectively serving in the same way as cloud credits in the cloud. So I think there's a lot of similarity to the cloud and data center world. And I think that's where we should draw the most historical lessons when thinking about this ecosystem.
Might kind of throw us for a whole different world here, but what's the bearish case for modularity in crypto? Like, why won't it come to fruition? Why won't this vision happen?
So historically, finance has done better in low latency and integrated environments. And part of that is because the UX of finance is that, like, the longer I have a delay, the more inaccurate a price or quantity or interest rate is, right? So I sort of can't tolerate asynchrony as much, right? Versus like streaming, I could totally tolerate asynchrony. I don't know if you remember, but like there was a long time where you'd have to like, you'd stream a video and then there'd be like, hey, it's buffering and it's like not loading. And then, like that's the asynchrony, right? Like you're waiting for the blocks of the video to come to you. They're coming out of order and like, oh, you maybe got too much from the end of the video and not enough where you are right now. And so the buffering was just like waiting until you got those. But you're fine with that, right? Like it's not, you didn't lose money. You lost a little time, but you're much more insensitive to that. And so I think the question is, are there financial applications that benefit from modularity? And I think, to me, the most interesting place that will happen is probably games, because like they inherently have this modularity, and if you're adding an economics model to them, that economics model has to interact with that somehow, between like the different characters, between different items, between all of the different components. Maybe it's not a very consensus view, but I just think that the bearish case for modularity is that like everything looks like everything in finance we already have, where it's like it's everything in finance we already have. It's better because it's permissionless. I can get whatever exposure I want. That part is obviously just a better thing, but that's something that's not unique to the modular ecosystem versus monolithic. I think it really needs to be something that takes advantage of, this idea that specialization at the cost of synchrony is, buys you some utility gain for your average user.
Are the components of finance expressive enough to take advantage of the specialization? Like to have one aspect of finance, like a lending market, run on one core, another aspect like a perps, DEX, and have certain specializations of finance run in parallel?
Yeah, so I think like one way you kind of get that is, I think this is not to make DA sound worse, not like it's not doing anything, but there's a sense in which DA exists because of like inefficient resource pricing in Ethereum, right? You kind of priced everything at the same time. You're forcing everyone to compete for sort of a fixed resource, and it's sort of like imagine if you went to a grocery store and instead of just scanning the items you wanted, you had to enter an auction where the auction was trying to sell you apples, grapes, and meat all in the same auction. Well, sometimes there's going to be a ton of people who want meat at the same time as you want apples, and now your apples are priced at the price of their meat, which is like not fair, I guess, to the vegetarians. And there's this resource pricing problem of like, hey, we have a single dimensional demand auction like Ethereum, and the alternative DAs are just basically saying, hey, actually, if we separate out this ephemeral data usage, now there's a lot more to that, right? Like you have to have sampling, you have to have all of the DAS, all the like client stuff, for sure. I'm just saying from an economic standpoint, that doesn't matter, right? The economics are pricing that as an option of like, if something went wrong, I can exercise this option to do something, right? So if I look at it from a pure economic lens, you can kind of think of, DA is like just adding in a form of dynamic resource pricing that like the main chain was unable to add to itself. Now, obviously, it's trying to, e.g., like the upgrade today. But this is one of these cases where specialization can be bolted on top from modularity, so you can take something that's already working and like make it more efficient. And I think that's another case where a sort of bull case for modularity is that it can fix things that kind of work later while they're live.
Yeah, it's an improvement, and it's quite funny. There was a panel in Denver, and it's like monolithic debate, and the monolithic kind of representatives generally agreed that they're going to scale in a modular fashion as they scale, which was it was interesting to kind of hear. I think last thing before we wrap up here, generally about like the current situation about block space. I'm a big fan of kind of expanding block space, getting rid of this scarce block space problem, but also like I feel like we could get to a point where there's too much block space, and block space loses its inherent value as being block space on Ethereum at some point, whether it's settled by an L3 and L2, app-specific chain, etc. What's your vision for how block space expands and contracts in the development of kind of this modular expansion, as we're calling it?
I think if this system is successful, it will look like cloud provisioning, where you expand and contract in response to demand. You're not, like you could imagine ephemeral blockchains that exist only for a certain use case and then die. And I kind of think one reason the modular world is better for that is that this idea of killing a blockchain is much easier to do in a modular world than it is in a monolithic world. Because the monolithic world, to kill it means you're killing the whole thing, right? Like you can't kill some subsection very easily. And so I think this idea of, one thing that I think is an interesting observation from actually, someone who I think is a sort of long time crypto person, was a Bitcoin maxi until very recently, for like a decade, sort of pointed out to me is like, he's like, when I first got into Bitcoin, I really valued this idea of immutability and the idea that, this thing has this form of object permanence. But in reality, nowadays, most of the things I value about blockchains is the verifiability component, much more than the immutable component. And the idea that users may have dynamic preferences that change over time for, like, maybe I care about immutability for this thing, but then maybe later, actually, it turns out we don't need it. But I really want to verify state because it's like, it's money. So I need to have the ability to verify things. I think that inherently is something that, is the world we're kind of moving into, I think. And I think the modular world allows users to choose the amount of immutability or the amount of trust that they want. Now, I would say, obviously, the project that's the closest to allowing parameterization of that entire spectrum is EigenLayer. I think people building stuff on top of Celestia could emulate a lot of that functionality, but I think if the whole system for being able to sort of choose how much trust you want, choose how much immutability you want, choose a lifetime like ephemerality, I think restaking is right now the only system that actually kind of touches all three of those components. And I think that's kind of the future we're moving to, where like verifiability is the core thing about blockchains, and everything else, you can pick and choose which properties you want. And the monolithic world makes that difficult. This pick and choose component, you have to take the whole basket or nothing.
Yeah, and the big thing with EigenLayer is, of course, not needing to secure your own economic, basically, validator set. You can launch chains without even launching a coin.
Right. And you can kill chains. You can kill the chains too.
Right, you
like
just kill them. Yeah.
Yeah. And I think it is. This is just a common thing. I think not just in the infrastructure level, but even in DeFi. Right. You're seeing a lot of DeFi protocols become much more modular and separate out their components. Whether it's Uniswap v4 like liquidity hooks, which allow you to separate out the actual execution and liquidity from like some rules around how execution happens, or whether you something like Morpho or Ujna or Euler, some of the newer lending markets, separate out the different components of instead of like sort of pooling everything. Like you still have pooled assets, but you can construct some rules on your assets, like, oh, I only want it to be used in this when a certain type of trend of lender I don't want to lend to, ... right? So I think this notion of the like I get to choose what subset of properties I want, that is the next 10 years of blockchain. And
Is latency not an issue?
So for lending markets, latency is very minimally an issue. It's only an issue for liquidations. It's usually people are not borrowing and closing their loan. It's not like a swap where it's like I might trade back and forth many times. It's a slow interaction, which is also why you have to be, but it also is higher risk, right? Like I'm keeping my capital at risk while lending. So it is sort of different. Yeah.
Well, thank you, Tarun, for coming on today and just being a part of Modular March. I feel like I could talk for another 3 hours, but very much appreciate some of your insights, man.
Definitely. Thanks.
Cheers.